I want to talk today about how we figure out the three-dimensional shapes of molecules. And the way that we actually do this, there are a couple of ways we can look at this. One of the ways is to look at a central atom and figure out how many electron groups or clusters it has around it. And since all of these electron groups are negatively charged, since they're made up of electrons, they're going to repel each other. Because they're repelling each other, they're going to get as far away from one another as possible. So the goal in determining the shape then becomes figuring out how we can get these groups as far away from one another as possible. And there are a number of possibilities that we need to consider. They're shown here. In most of the molecules we look at in Chem 101 and 102, as well as 203 and 204 actually, we will be considering the first three possibilities. When we start looking at molecules that can expand their octet, can have more than 8 electrons around them, we got two other additional possibilities as well. When a central atom has 4 electron groups or clusters around it, the shape that puts these clusters as far apart from one another as possible is shown here. This general shape is referred to as the tetrahedral shape. An example of this is the molecule methane, and you can see that the angle between all of the groups is 109.5 degrees in methane. In a tetrahedral structure, that is the bond length that an ideal tetrahedral structure would adopt. 109, not length, but angle, the ideal bond angle a tetrahedral molecule would adopt is 109.5. When we have 3 clusters around a central atom, we're looking at a shape like this. This is actually a planar shape. The molecule is flat. We refer to this as trigonal planar, and the bond angle in a trigonal planar molecule is centered around 120 degrees. If we only have 2, and this example here is actually formaldehyde, if we only have 2 electron clusters around a central atom, the general shape is shown here. This is referred to as a linear shape, and the bond angle in a linear molecule like carbon dioxide is 180 degrees. The 2 additional shapes I mentioned earlier, trigonal bipyramidal and octahedral, a little bit more complicated because we have more groups around it. In the first one with 5 clusters, we actually have 2 different bond angles, the axial bond angle and the equatorial bond angle, whereas for the octahedral, the bond angles for the axial and the equatorial groups are all 90 degrees. As I mentioned, we encountered these last 2 configurations in molecules where the octet can be expanded. So for instance, the example shown here is PCl5, and the example shown here is SF6.